Hello, this is the AP Calculus Free Response Question, FRQ 2014, number 4, by Divyavrata Mukhopadhyay, Period 2, Teacher for. So we start on apcentral.com where we find the AP Calculus AB Exam section. We can move down the page and it gives essential information upon the AP exam. We'll also find the free response questions. On the side, we can find sample responses where you will get other students' responses. And we can go to the AP Calculus question and we'll scroll down um, all the way to question number 4, which is the question we'll be focusing on. And on the next slide, we'll start to do the question. However, before we start on that, I want you all to know
you smart. You very smart. We the best.
our first step is to read through what is given to us. So we are given a chart with values t and VA of t given in minutes, VA of t given in meters per minute. Train A runs back and forth on an east-west section of railroad. Train A's velocity measured in meters per minute is given by a differentiable function VA of t, where t is measured in minutes. Selected values for VA of t are given in the table above. Now we can move on to section A. Find the average acceleration over the interval 2 less than equal to t less than equal to 8. So average velocity is always given by a slope function like y2 minus y1 over x2 minus x1. In this situation, it's just going to be the same thing, but we'll write VA of t2 minus VA of t1 over t2 minus t1. Okay, this function here will give us the average acceleration of train A over the interval 2 less than equal to t less than equal to 8. So all we need to do is take these values and use the values 2 and 8 and plug them in. So we get negative 120 minus 100 over 8 minus 2, which is negative 220 over 6, which can simplify to negative 110 over 3. And our units will be miles per minute squared. Minutes squared because it's basically minutes over minutes twice, so it becomes minutes squared. That's the answer to part A. Okay, on to step B. In this problem, it asks, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t within 5 to 8? Give you a reason for your answer. Whenever we have a question asking for a value within an interval, we must think to intermediate values here. This is a definition below from the book Calculus, the early transcendentals, and it states that suppose that f is continuous on the closed interval a to b, and let n be any number between f of a and f of b, where f of a does not equal f of b, then there exists a number c in a to b such that f of c is equal to n. In this situation, the question is asking to prove that t exists. So to do that, all we need to do is prove that f is continuous, and that f of a does not equal f of b. So we have it is given by a differentiable function, which means that the function is also continuous, and it's also given in the table that the f of a does not equal f of b, and all we need to do to show that IVT applies to this is to show that f of 8, VA of 8 is less than negative 100, which is less than VA of 5. Sorry if I've been saying f of x for the whole time, but f of x is equal to VA of t, if that wasn't clear to you. So we have negative 120 less than negative 100 less than 40. So the second part of the problem would be of the answer would be to state in a sentence, by IVT, there is a time t within 5 to 8 such that VA of t is equal to negative 100. You must state it like that in the conclusion. On to the next part. Now we move on to part C. So it's asking at time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from origin station at time t equals 12. Use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of a train at t equals 12. To find the position expression, at s of 12, which is the position function because it's s, we must do s of 2, which is equal to 300, and plus integral 2 to 12 of VA of t. That will the antiderivative of v is s at all points. So to find now we must write the value out of integral VA of t from 2 to 12. A trapezoidal sum function is b minus a by f of a plus f of b over 2. So we find the difference between t's to be 3 for the first two parts of the subintervals, and then we add the y values together over 2, and we get 3 by 100 over 100 plus 40 over 2 plus 40 minus 120 over 2, and then we get plus 4 by negative 120 minus 150 over 2, because the difference then becomes 4 between the t's, and then the value of that comes out to be negative 450 when all worked out, and we must add 300 to the negative 450, which gives us negative 150. That is its position, and we know that it's addition in the first part, s of 2 plus 2 to 12, because it's moving east, which is going away from the origin station. Thank you very much, and on to part D. Okay, now we move on to part D. Okay, here's how it goes. It says a second train, B, travels north from origin station. At that time, t, the velocity of the train B, is given by VB of t equals minus 5t squared plus 60t plus 25. And at time equals t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. Okay, so first we can recognize that this can be modeled using the Pythagorean theorem. If you don't remember, it is, one second, a squared plus b squared equals c squared, right? This equation right here. And then we need to determine allot values for these, and we can have a variable equals a position, the lowercase b is equal to b position, and c is equal to the distance between a position and b position. So we differentiate the Pythagorean theorem, and we get 2c equals dc over dt minus 2a equals by dA over dt plus 2b by dB over dt. These set of values can be solved for at the current moment, and they're already given in some situations. DC is what we're solving for in this situation. Sorry about that. I will delete that from there. And we are solving for DC over DT. That's the main thing of this. C is equal to 500 by Pythagorean theorem. We solve for C given A and B are equal to 300 and 400. Now we can solve for VB2 of 2, which is equal to dB over dt, because it's the velocity of the B function. So we get 125 for VB of 2, and dA over dt is already given in the graph right here as 100. So those are all the values we needed to solve for. So all we need to do now is solve for dC over dt. So we have 500 by dC over dt is equal to 300 by 100 plus 400 by 125. To clarify, we are using this equation to solve, okay? And we canceled out a 2 here because it's not very necessary. We can cancel it out. Okay, and when we solve for it, it's 80,000 over 500, which is equal to 160 meters per minute. That is your solution. Thank you very much.